So let's get started with our next section, the 6.0 mobility areas. Okay, let's just start with an overall definition. What is a mobility area? It's a tool set to create, store, and utilize user-defined geographies inside of TBEST. With a mobility area, you can summarize transit service, performance, and markets as in a geographic context. And some examples of mobility areas that you could define and would be relevant for, transit agencies would be service area definitions. We've talked about that. Rural areas, corridors, taxable areas, mobility on demand areas. And, there are many, many more. Cities could be something if you have multiple cities in your service area and you want to be able to evaluate service within cities. That's something that's obviously something you can do. So there's a wide range of geographies that you may want to evaluate, and it could be something where it's project related. You have a specific project area that you're working with as well. So there really are no limits on the geographies that you can define with the mobility area, and there are several ways to create them as well. You can create them using any kind of shapefile that you would add to the map or user layer that you would add to the map. But there's also tools for shed generation. So with this shed generation, you can create transit sheds, walk sheds, bike sheds, wheelchair sheds, and drive sheds for kind of shared mobility assessments. So if you want to, evaluate on your a particular set of stops, a 10-minute bike shed that's accessible from those stops because you want to that you have bikers that use that system and you want to know the markets that it can access those stops within a given amount of time on a bike, then you can do that. So and likewise, if you have a drive shed around a park and ride, you want to know what your drive area market is. It's very easy to define a drive shed and then evaluate the market within it. So we'll go through lots of examples of how these work. All right, so it kind of starts out with the mobility areas toolbar, which is an optional toolbar that you can add through the view menu, where you can define different types of mobility areas to create. So the walk shed, bike shed, drive shed, and wheelchair shed are defined from OpenStreetMap network and are time or distance based. So essentially, as an example, if you look down in the 10-minute, let me just illustrate what I'm talking about here, this 10-minute walk shed from the UF Stadium. So all I did was select the walk shed option, and you can select here instead of distance, you can have time as well, and time of 10 minutes, and just click on the map, and then it will generate this walk shed from that location on the map, based on your distance or time inputs. So very easy to create one of these, and you can interactively add them, multiples if you wish on the map, and there's lots of other options for generating them as well. The other option is a transit shed. So transit sheds are different in that they are actually defined from the TBEST network accessibility build, which is a time-based build. So essentially what this accessibility build, this network accessibility build, is a OD matrix that you generate, stop-to-stop OD matrix for your stops in your transit network, your TBEST transit network. So it's not based on OpenStreetMap, it's based on each individual network that you have in TBEST. So each network scenario, you can create an accessibility build or more that have certain parameters in them for destination access from every stop to every other stop. And using the interactive part of this, if you select this transit shed option, then you can click on any point in the map and it will show you your destination accessibility through the transit network that you've defined, right? So whatever it could be, your base conditions, it could be alternative conditions, but you can show your accessibility through the network. The next option is Drive Path, which again, this one does use the OpenStreetMap. In this case, it's kind of similar to what we were doing yesterday with digitizing, using the shortest path between a point you click on the map and using the street network to your cursor. So it just kind of follows the path along the roadway network, and then you would just double click, and then it would buffer around your alignment you digitized. So it's kind of just a way, like if you were defining a corridor and you wanted to say, well, my corridor runs from point A to point B along this network, then you can use this drive path tool to say, well, this is the drive path that it actually takes. And then it would create whatever buffer that you would want in terms of distance around that drive path. The other options are very simple, which kind of point buffer and linear buffer in terms of distance. And then polygon is freehand, or the option here, and this is an important one, to import shapes, right? So this is where you would have a user layer, a polygon user layer that you would add to the map. It could be any user layer. And then you could select the features from it and add those in as mobility areas. So that's how we would easily get to we'll just clear this off and go back to something like this. So this is a county, Orange County. So obviously I didn't digitize this into TBEST. I added a user layer, selected Orange County from the user layer using the mobility area tool set, and then just imported it in as a mobility area. So, clearly you can do that as well. So here are some examples of just a little bit how this looks. So mobility areas are combined with other TBEST tools such as market analysis and the query tool, network accessibility for layered multimodal analysis. So just in terms of what maybe a walk buffer looks versus a walk shed. So the conventional 0.25 mile walk buffer looks something like this, where you can see that kind of the circular patterns, around the stops. Whereas that same set of stops, if you run the walk shed, they look very different, right? So clearly there's barriers that are enforced through OpenStreetMap data, so that if it's not walkable, it won't be accessible via walk. So these sheds tend to be smaller because there are, clearly probably going to be more barriers in place where walk access isn't allowed. So very valuable piece of information here, very easy to generate in TBEST, that you can analyze your walkability from any set of stops or one location. So another example here is a 5-minute bike shed from bus stops with greater than 15% zero vehicle household share. So what we did was we used the query tool, which we're going to cover just in a little while, to select all those stops where they have a greater than 15% vehicle household share. So from that selection, then we can then create a 5-minute bike shed from those stops, right? So once we make the selection, then we can create the bike shed, and it might look something like what this map is below, where we can create the shed and then perform a market analysis on it, right? So, so it's just, integrating all the tool sets that we have in TBEST to come up with an analysis, a more detailed analysis than maybe is called for in a TDP or is called for elsewhere, but maybe it's a workflow that you're trying to solve and something that TBEST can answer. Okay, so here are just some examples of mobility area types. I won't go through all of these. It's more just an example of what we were just talking about. Just keep that in mind that it's here. And again, this is a full reference for all of the different tools that you have on the mobility areas toolbar. And we had just talked about this option, for the creation of them, and the distance or time option here. This is where you would actually, this is your click, basically point and click on the map tool. So This is digitizing on the map any kind of shed that you will want to create. The number 4 is the select polygons as mobility areas. So this is enabled if you're using the polygon type and if you have a user layer available that you can select from. This is also very helpful. This is the create market shed from selected features, and that would be from selected stops or segments or routes. So any of those selection types, you can create sheds from those selection types, any of the different sheds, except for maybe transit sheds. Just keep that in mind. You can also select, so if you have a mobility area on the map, you can select routes and stops using a mobility area. You can zoom to it, you can clear it. And then we have the analysis toolbar where you can run mobility area service reports, including observed ridership and estimated ridership reports that would be inside of the mobility area. You can run SE reports, land use summaries, and transit network accessible. So what this does is if you have a mobility area on the map, you can determine the overall transit network accessibility from that mobility area. So it's kind of actually combining multiple mobility area types to create an accessibility feature that shows you where you can get to from any location inside of what area you've defined on the map. So that area might be a corridor, and you want to know where can I get to in the overall network, transit network that I have defined in TBEST from within that corridor. So something like that. All right, some other management tools. So whenever you do create a mobility area, and we looked at mobility areas when we were first discussing the TBEST Explorer window, and for our Gatorville transit system, we had preloaded some mobility areas. So they get stored under the in TBEST Explorer. So whenever you create them, I guess maybe I need to back up one slide for a second. One important piece of the puzzle here is that you can save them here. Right? So this is the save button. So as you're creating any mobility area on the map, when you want to save it, you don't have to save it, but if you want to, you use the save button. And when you do that, it will then save it into your TBEST Explorer window in the transit system that you're currently in, and it will then be stored here. So under mobility areas, right? So this is our links transit system, and then whatever mobility areas we're creating, no matter what scenario we're in, doesn't matter. Any mobility area that we create gets stored here for this transit system. All right, so obviously you can open them in the map. So once you've saved them, you can open them. You can create reports on them. The same kind of mobility area reports, network accessible markets, land use markets, market analysis, etc. You can move a mobility area to a group. So we do have groupings. I think we showed that a little bit yesterday as well. You can create mobility area groups just like you did with the network scenario groups. You can create mobility area groups to better manage your mobility areas. You can copy them, you can merge them together, you can erase an area using a mobility area from another mobility area. So basically erasing it, it's kind of a GIS type of functionality and feature. You can move them across transit systems, and you can change the properties or the names of them. So a full management capability, analysis capability, creation capability, and integrated all throughout TBEST through different mechanics, whether it's defining the service area, using the query tool where you can constrain by a mobility area geography. They're used in the parcel editor if you want to use a constrained geography that might be a TOD or a DRI that you want to generate parcels within that area. They can be used there. Just lots and lots of areas within TBEST that we'll discover as we're going through the afternoon to where you can use mobility areas. Okay, so one of the basic reporting features of mobility areas is a mobility area service and performance summary. So our example here is showing an area. So this was probably, a 10-minute bike shed from a given location around the University of Florida campus. And what you're seeing is in the map that we ran a service and performance report, and what it does is it shows you the routes that are operating inside of the mobility area. So in this case, it's showing a map. There's lots of routes that are operating just in this context, in this area. So it shows you the map of that and constrains the TBAS map to just this area, but also produces this report, which is a mobility area service report that actually details every route that's inside of this area, how that's running in here, and constrains all of the cost, the hours, the miles, all of those variables get constrained to just what's inside of this area. So we've looked at this service report in the past just for all routes at the route level. So this is a different look at it in that the routes are then constrained by geography so that you can see in total what's happening inside of this geography, and it could be any geography, right? So in total, the operating cost inside of just this area on a weekday basis is 9,378 for all routes, and you can look at individual ones as well. The percent of the route service. So in total, Route 8 has 1.3% of its total service is inside of this area. And likewise, 20.8% of Route 34 is inside of this area. Another valuable number here is the percent of the system service. So in total, for all of them, it's 9.5% of the total system service is inside of this area. So if you're calculating this for a corridor or a project area and you want to know how much of my service is running inside of this particular boundary or geography, it's very easy to do that inside of TBAS, plus get all of your performance metrics inside of that area. If you have your APC data, you can stop level ridership data, you get all of your performance metrics from your observed data for this whatever geography you have in your mobility area. Okay. All right, so just some mobility area or COA type planning applications that you can use for mobility areas for in terms of multimodal access to transit, as well as analyzing emerging mobility options. All right, so we talked about the polygon or shapefile import, where you can define jurisdictional level maps or overview of a study area. So an example would be, you have a service area, or maybe you're operating just within a specific county or a city, and you want to have the city maps, just like we showed the county map, plus an overview, which might be the population and employment inside of that study area. So instead of evaluating, transit necessarily, it's more of just the context of the area, right? So you don't have to really involve transit in this particular line item, right? This could just be, hey, I'm just evaluating a study area. It really isn't related to transit. It's more just, hey, I want to look at what the markets are or the area is around in my study area. The other is Walkshed. And so walkability relative to transit via the sidewalk network. So we just had an example of that where the barriers are in place to define walkability relative to transit. The bike and drive shed, obviously this is travel markets. We can perform gap analysis, bicycle and micromobility analysis relative to transit or just on its own. The wheelchair shed is stop ADA accessibility. Now this one is a little bit loaded because what you get from the wheelchair shed is going to be maybe not as detailed as what you would do if you're actually doing ADA accessibility in detail, where you have ramps and all the different type of facilities that you have to accommodate ADA. The wheelchair shed in T-Best is more of what is the slope of the area, and if you're in a wheelchair, is it too steep for you to operate effectively? Do you have barriers in place to getting around in a wheelchair? Things like that, where it's not as detailed as maybe you would have in ADA compliance, but it certainly is something where you have at least a screening of your ADA accessibility around a stop. Now, I will note that all of this, the walk shed, bike drive, and wheelchair shed are all tied, I mentioned this, to OpenStreetMap, right? Which means that OpenStreetMap, as you all probably know, is editable, right? Anyone can kind of go in if they get approved and edit in OpenStreetMap and add information that might be relevant for your project if you're using it for T-Best. So if there is more ADA kind of compliance and more information that can go into OpenStreetMap that might help with these wheelchair sheds, it's not impossible for you to go in, edit in OpenStreetMap, and then have that show up in T-Best, right? Now, I will tell you that we have a server that we host for our OpenStreetMap data, and it's not dynamic. We have to pull it every once in a while. We pull new data from OpenStreetMap to put in onto our server. So there's a little bit of a lag time, but certainly if you're editing and you're like, well, I need to see this in T-Best, you can just, email us and say, hey, we made this change. We would like to see it in T-Best, and then we can work on pulling that data and make it available. So, all right. So drive shed, you have park and ride analysis, competitiveness with transit, also very valuable in terms of evaluating park and rides, right? So park and rides are their own kind of thing where it's not a walk access, where T-Best is mainly a walk access model. And so if you want to evaluate a drive shed from a park and ride to evaluate markets within that drive shed, very easy to do in T-Best using the drive shed tool. I will also say that all of these are very handy in also evaluating markets that maybe you would want to capture in T-Best. Remember, we were talking about overriding what T-Best, whenever you run the ridership estimation model at the stop level, it will calculate values that are accessible in terms of walk access from the stop, and then you can override them. So if you do have information on bike and drive sheds, or especially for park and rides, where you have an extended market that is really kind of accessible from that and who would use that park and ride, then you can maybe override what's in T-Best to have your drive shed number rather than the walk access number that T-Best would calculate. So this is a chance to use some of these tools to maybe override some of the values that are in T-Best in terms of what the model calculates for stop level population and employment. Okay, so linear buffer and shapefile import. So we talked about that. Just our example was the county level data, importing that. The corridor analysis, area studies, mobility on demand zone analysis. So clearly, most everyone, if they're running mobility on demand, they will have the zones either in a shapefile. They might have them in ArcGIS Online. Some folks do. And all of those would be data that you can pull into T-Best and utilize that as, create mobility areas from it, and then utilize it for analysis inside of T-Best. And then we have our transit network shed. So bus stop, walk accessibility, and multimodal access to transit. All that's kind of a possible here, and something everyone, lots of tools, lots of ability here to create different geographies and assess those geographies and create reports and maps that would help you along with your service and strategic planning. Okay, so just an example of importing and then exporting a geometry. And in this case, we're dealing with the city of Gainesville. So this is the outline, or basically the shape of the city of Gainesville, and kind of overlaid in T-Best. So you can see our routes in the background here. It's sitting on top of it. It's its own shapefile. And all we need to do is select it using our TBEST tools and our mobility area tools, and then save it, right? So this import is a mobility area using the Polygon mobility area import. So we've saved it as the city of Gainesville. You can see right here the name on it. And so we have in our map, in our saved mobility areas that. So very easy then to run a socioeconomic market analysis on that mobility area. So in this case, the population density within the mobility area. And then within the TDP, we have a population density map for the city of Gainesville that we can easily export to ArcGIS Line or Pro, create the map that we want, or just use the TBEST map as it is, and use that inside of our TDP. So very simple kind of workflow to support density mapping for any geography. In this case was a city, but it could be anything. All right, so let's run through some exercise work here. Any questions? Oh yeah, here we go. All right, so the question is, would there be any mechanism to incorporate planned or proposed walk or bike network for sub-area or corridor planning efforts? These wouldn't necessarily belong in an OSM edit, but may be contemplated as part of a study. Yeah, so whatever you would have in a shapefile or the mobile geodatabase or an ArcGIS online layer can be added to the TBEST map and either saved as a mobility area. We actually have a tool that we're going to look at a little bit later for market assessment and service assessment using just a layer that you add. So it will summarize basically the markets or the service within every geography within that layer. So if it's all your mobility on demand areas in one shapefile, it will go through and summarize all of the markets and service and everything inside of each one, and then provide a report to you for each one. So yes, so oh, I see. So the question is pertaining to whether they can be integrated into the network for defining a travel shed plan. I don't think so. I think the question is in the tools that we have, can you say, well, I have a proposed walk or bike network. No, because we're really just working off the OSM. So unless you can do a proposed OSM, which I don't think you can, then we're just working on what exists, not what will be. So we're not dealing with any proposed network as it relates to what would be in there in the future. I think that's what your question was. Yeah. Okay. Got it. All right. Yep. Thanks. All right. Very good. Let's go through this, and I'm sure questions will come up as you're using it, and we'll go through it in some detail. And anything that you all would want to see as we're walking through, just raise your hand or put it into the chat. And of course, Sam will be in the breakout room. So if you want to go in there, you have questions directly for him, that's fine too. Either way is fine. Okay. All right, so on 6.0 mobility areas, create a mobility area bike shed from a map location. So open the fall 2024 network scenario. Let's go and double click on it. All right, so right now we don't have the mobility areas toolbar visible. So there's a couple of ways for us to show it. So right now we have the import alignment. We used this yesterday, this toolbar. Over on the right-hand side, you have toggle route pattern alignment toolbar. So we're just going to toggle that one off. And then right beside it, you have toggle mobility areas toolbar. So now we can turn that on. We can also get to it through the view menu. So view here as well, you can get to it. Either way is fine. Okay, use the mobility areas drop-down menu to select bike shed from the list. So we'll use our drop-down to select bike shed. And instead of doing distance, we're going to do a time-based shed. So we'll switch, this is a drop-down, so we can switch this to time. And automatically it will select 10, but we could click here and then change this number. So if we wanted it to be 20 or 30, we could certainly do that, but we'll just stick with 10. All right, once we've done this, you can see that our create mobility area from bike shed, that tool is now active in the map, and we have the crosshairs in the map. So it says use the cursor to click a point on the map. All right, so let's just zoom in and click right here at this intersection. Doesn't matter, we're just kind of playing with it at this point. So it's just a general bike shed from this location out into the network from that location, right? A 10-minute shed. Item 4 is to add additional sheds to the existing mobility area. Hold the Alt key down while clicking the map. So if I wanted to kind of combine a couple of areas here and say, well, I also want to know the bike shed from this location, then it would actually combine them into a single shed rather than separate. If they didn't touch, they actually overlap in this area. So it creates, it merges them together and creates a single shed. All right, item 5 is create a service area or service report using the mobility area toolbar analysis mobility area service summary report. All right, so let's do that. So if we go to analysis, mobility area service, and service summary. So very quickly, it will analyze what's in this area and show us the routes that are in service in this shed that we created, the bike shed that we created. And in the report, it gives us the service, right? And the costs, the percent of the route service, percent of system service. This is for the weekday. If we wanted to annualize this, we certainly could. So here's the annualized operating costs for it. So if we scroll to the bottom, we see that we have 14.9% of the system service in this area, and on average, 21.6% of route service. But of course, each individual route will be very different in the service that's in this particular area. Okay. All right, so we'll just close that. So item 6 is use the mobility area analysis menu to create additional reporting for estimated and observed transit service performance, socioeconomic conditions, and land use conditions for the active mobility area. So the active mobility area is what we have on the map. So again, we'll go to the analysis, and this time we're going to select observed ridership, observed performance summary. Okay, so what this is telling us is based on the APC data, the observed boardings for every route and the total for within the area, the observed lightings, and this is for a weekday. The round trip length, and these are just the service levels we saw in the other report. Revenue service trips, boardings per service trip, service hours and miles. So basically our actual observed performance within this area, and of course our percent of route service and the system service. The estimated summary will give us our T-best estimated total direct and transfer boardings plus total boardings, and then all of our cost and boardings per service mile, hour, and trip. Okay, so we can also very easily create a socioeconomic summary. So this is a summary report just for the mobility area. In this case, it's the bike shed. And it gives us the total population, the density, the minority population, Hispanic, limited English proficiency, over 65, under 18, and then it goes to the households category. So these in the darker green are households, and then it switches to jobs. So job density, service, commercial, industrial, and then acres. So this is the default profile for this. Now we have other profiles. So you go to population, and then the variables change to just population variables, and then their percentages of the total. So 52% female, 48.6% workers, etc. Right? Now, what you can do here is switch to demographic counts. So instead of showing the percentages, you can actually show the counts. Either way is fine. All right. You can also have a Title VI summary. So this now gets into some of our Title VI reporting specifically for this area, right? So we can see that our low income percentage is 29, our minority percentage is 29.5. And what's interesting about this is when I'm hovering, what you're actually getting are data links. So when the link is active, you're hovering over it, you can just click on that and it will generate the market analysis for you. So then now you open up to a distribution of minority population within our bike shed, right? And so from here, we have our bike shed as our header. We're in the Gatorville fall 2024. Our distributions, our minority population distributions are defined here in terms of percentage up to 100%. And then the distribution in the map. So all of these are kind of related, and we'll get to how the market analysis kind of works. But very quickly, you can evaluate any one given variable that is within the report and pop it up and use it. Okay, so we have a question. How are revenue hours and miles allocated to a mobility area? Well, they're just, obviously they're constrained. So whatever the service on any one route or route pattern is and the stops that are within it, we just constrain the actual alignments to be within it and calculate the service that's in it, right? So we know all the information about the route and its service, so we can then constrain it to just this geography and then calculate the totals. Okay, another question. Do the reports reflect the statistics for all intersecting block groups, or is there area-weighted interpolation or similar process applied to account for the differences in geographies between the reporting area and the underlying data? Yeah, it is an interpolated area-weighted accounting of the census blocks and block groups. That's correct. Another question also, how are the demographics allocated when a mobility area cuts through a census geography? So yeah, it's just the same kind of area weighted. Those are very similar questions from two different people. So yeah, so it's the interpolation. Yeah. So very easy to get to this information. Any of these variables you want to pop up, you want to see Spanish speaking, you just click on it and you pop up the map. What you'll notice too is that this is a different geography level because this variable, the Spanish variable, is at a different geography level than the minority population because one is from the 2020 census, the origination of it, the minority population, and the Spanish speaking is more of an ACS or block group level variable. So yeah, so we're using different geographies and we're assigning them. So kind of going back to yesterday, and I don't know that I explained this during the actual exercise or the lecture, but remember we created the WMATA transit system and we use the socioeconomic data configuration tool to do it. So part of that process is you're downloading the census 2020 block data demographics and you're downloading the ACS 2023 demographics. The ACS is at the block group level generally, and the census 2020 demographics are at the block level. So With T-Best, what we want to do is try to keep the lowest level of geography that we can, because walk access is very important to T-Best, and certainly block level information is kind of better in terms of distributions and smaller type of geographies. It's better for assessing distribution in terms of walk access. So in that process, what happens is basically the control totals from the ACS at the block group level are pushed down into the census blocks that are from 2020. So if you have 2023 data from the ACS, it's newer data. It's essentially kind of incorporating the growth that's happened since 2020, and we want to make sure we're accounting for that. So we use the control totals for the census 2020 block variables that match up in the census and the ACS, and use the ACS as control totals to push that down into the blocks. So whatever that growth rate is at the block group level gets pushed down into the individual blocks to escalate those numbers at the block level. So we're accounting for the growth in the block level down to the geography level at the block level that we want. So hopefully that makes sense. It's part of our overall process here is to make sure we're using the latest data, but also getting the geography level that we want, which is primarily at as many attributes as we can at the census block level. Okay, that was a little bit of a tangent. All right, so really you're just interacting here. So, and any of this can be exported to Excel, of course, as you're, evaluating any of these markets, you don't actually have to come back, close this and come back. You can switch here as well. So if I want to go to employment, I can easily switch over to employment. One of the nice tools that we have in this as well is the ability to just copy not just the map to the clipboard, but essentially the market analysis to the clipboard. So if I click this, you'll see it kind of flicker, and then I'll say it's copied to the clipboard. So what I can do is I can open a new Word document and just have it here, bring it over. And if I paste this in, it shows me not just the map, but it retains the header information. It takes out any buttons, and it basically gives you your distribution, your chart, and your map all in one screen capture, so that you can insert that directly into a report if you need to. All right. So we're going to cover this a little bit more later, the market analysis, so I won't dig into that too much at this point, but we can also switch to land use summary. And so this is a newer report for T-Best 5. So we didn't have this report in T-Best 4.8, where we're summarizing, instead of just socioeconomic, now we're summarizing the parcel data, right? So you notice that it's a default profile. Our summary field is person trips. So if we go back to, we were talking about yesterday, ITE trip generation rates are basically our person trips. So that's the trip activity, the person trip activity at every parcel. So what we're summarizing here are the person trips or activity levels that are coming out of this mobility area. So the trip making, right? Doesn't have to do with transit necessarily. It is specifically just activity levels for person trips as ITE trip generation rates. So what you can see is you have the person trips total 1.5 million, the person trips per acre, single family, multifamily, total residential, shopping, office buildings, hotels, schools, hospitals, government, community support, other land use. You can switch this to other profiles. So you have residential, you have commercial. So if you go to these, you have even more detail of all the different land use types. Remember, we showed the spreadsheet yesterday? All those land use types that are defined from the Florida Department of Revenue are showing up here in our land use report. And again, the data links are here too. So if we want to show, I just want to see where the supermarkets are in this area, then I can quickly build that map to show okay, here are the supermarkets in my area. And likewise, community shopping centers, we want to see that map. So here are the community shopping centers. So very easy to plug in and show distributions of different profiles. You can also switch this to building square footage. So it can be not just person trips, but building square footage. And remember, this is internal heated square feet. You can show population, dwelling units, and even parcel count. So this will give you a total parcel count for, in this case, commercial within this area. So that's kind of handy. And go back to person trip. So basically functions the same way as our socioeconomic report, but has some different variables in it and very handy to use. Okay, so pretty big tangent there. All right, so let's go back to saving the mobility area. So I'm on item 7. Use Save Mobility Area button to save the shed to the Transit System Mobility Areas folder. So here is our Save Mobility Area button. It's not the same as our Save Scenario. It's on the toolbar, the Mobility Areas toolbar. Okay, we're going to call this 10-minute bike shed. Okay. All right, so we've saved it. And now it should appear as a 10-minute bike shed in our list. So basically we could, if we want to, we can remove it. So we can use the clear mobility area button on the mobility area toolbar and it goes away. And then we could just double click on it in our list and it comes back up. Okay. Next item, create a walk shed mobility area for Route 88. So we're going to open up our TDP constrained plan. So I'm going to close this scenario and open up the TDP constrained plan. Okay, on the mobility areas toolbar, select walk shed as the mobility area type and change to distance to 1/4 mile as the value. And item 3, use the mobility areas toolbar, select the create market sheds from selected features, market shed from selected routes option. So mouthful, but it's basically this button, create market shed from selected features, market shed from selected routes. Oh, sorry, I missed a step. I didn't select Route 88. So we just need to select 88 and then run this tool, market shed from selected routes. All right, so what it will do then is create from every stop that's on this alignment, it's going to create a walk shed, a 1/4 mile walk shed around that stop. And then we want to answer some questions. So which transit routes are in service within the Route 88 walk shed? All right, so we can come up to our analysis and say, get our service summary. And while we're not going to list them all here, we can see that there are 24 routes that are in service in this area. And we can get their, how much service they have, et cetera, if we need to. What is the estimated ridership performance within the area for area in boardings per service mile? All right. So we can go to analysis and our estimated performance summary. Okay, and within the area, we have a total boardings per service mile is here. Boardings per service mile is 24.1. So if we use our annotation, I can just kind of circle that. Boardings per service mile, here's the column, and 24.1 within that walk shed. All right. what is the population density and employment within the watershed? Let's clear all of that and close this. All right, population and employment density. So if we go to our socioeconomic summary, our population density is 0.46 and our employment density is 5.0. And the total employment is 12,564 jobs. How many zero-car households are within the watershed? All right, so zero vehicle is 6.4%, but if we change to our demographic counts, that's 266 households that are zero vehicle within the watershed. Okay, great. So next. All right, import a mobility area geometry and summarize. All right, so this is exercise part 3. Open the TBESS map control panel. So here's our map control. We're just going to pin it. And we're going to go ahead and clear off our existing mobility area. So I'm going to click the clear mobility area. That goes away. And we're going to add data. So we're going to select a local data source. So we're going to click the add data button on the map control, local data. And we're going to select from our data shapefiles directory, which is here. So if it automatically forwards me to where I was last, but I needed to click into the shapefiles folder. And there's an MOD zones shapefile in here. So we can just say, okay, it will add that to our map. Okay, to add labels to the MOD zones layer, right click on the layer in the map control list and select layer properties. So on my MOD zones in the map control, I'm going to right click on it and select layer properties. I'm going to add a label and then use the name field as the label field. And just say, okay. All right, so now we see where we have our MOD zones are labeled, and we can clear the selection of the route so it's a little more clear. So we're dealing with this. One other just kind of small thing you can do, you can see how the labels for the routes are kind of overriding or sitting on top of this. You can easily right click on the map and toggle off the route labels. So now they don't show up at all. So it's a little more clean map that you can use. All right. Ensure that the mobility areas toolbar is visible. So it is visible. Use the mobility area dropdown to select polygon. So right now it's at watershed. We want to select the polygon option. So what you see is that it enables this select polygon features as input to mobility area. We want to select that option. And it will pop up this selection layer and automatically go to MOD zones because that's the only user layer that we have that's selectable. So that's a polygon layer. So what we want to do is use this now to select MOD zone 1. So right here is MOD zone 1. I'm just going to click on it and it selects it. So now this is selected. And all we have to do is click the save button. I'm going to switch the page. So once this is selected, I click save. And we're going to call it MOD Zone 1. And say OK. And now it's saved, right? And it's active. All right, so we want to go ahead and remove the selection layer. So we're just actually going to use this toolbar to remove selection layer from the map. And that goes away. Yes, I'm sure. And now MOD zone 1 remains as our mobility area. All right, so I'm just going to repin the map control so we gain some area. I'm going to close this. All right, so You can now use the analysis menu in the mobility areas toolbar to find ridership, socioeconomic, and service for MOD Zone 1 specifically. So what routes are operating inside of MOD Zone 1 and what are their total weekday revenue miles? So we go to analysis, mobility area service, and the service summary. So we can see the routes that are operating inside of MOD Zone 1 and their total weekday revenue miles is 5516 inside of MOD Zone 1. What is the weekday cost of operating fixed routes within the MOD Zone 1? It's $3,818. What is the number of weekday stops served? So there are 94 stops served in total in MOD Zone 1, which is right here. And here are the revenue service miles. And weekday operating cost is here. Okay. Yeah, that